In any event, thank you all for joining us for our October meeting. It's been a journey just to get just to get started, but this is our agenda for today. This is what we typically run through when we do have our club meetings. For anyone joining us for the first time, we are a relatively new club. We'll be hitting 2 years in January, believe it or not. So it's a pretty exciting time for us, and I'm happy you're here. So this is our mission statement, but it's all to say everyone is welcome to come to our meetings. No astronomy knowledge is required. We have some folks that have looked through the telescope for their first time with us here, which makes us very happy. In fact, if you do have a telescope at home and you're having issues with it, we do encourage you to come bring it with you at our next meeting. Even if it's not clear, we might be able to take a look at it, help you get familiarized with it as best we can, but it is open to everyone, children and adults alike. So typically I'd be introducing a presenter today, but that actually fell on me. So today I'll be speaking about a brief history of 3D printing on the International Space Station. This topic is very close to me, only because when I started my volunteer work with NASA, I was really interested in astronomy, but then I recently had gotten into 3D printing. So a topic like this just really melds both topics together in a nice way, which makes me very happy. But before I get started on the presentation, I did want to ask the group, is everyone here maybe familiar with 3D printing? Do you have a 3D printer at home? Have you gone to a makerspace and fiddled with one at all? By show of hands, couple? Okay, great. And to be honest, it's not required for this presentation. I will be going through a little bit of an overview, an introduction into the 3D printing technology. But this is the agenda for the topic that I'll be speaking to today. I'll do an intro on 3D printing technology, talk about early experiments and preparations to get us to the International Space Station and printing there. I'll go through some milestones on the ISS, and then talk about the impact and future prospects of 3D printing in space. I have questions at the end, but by all means, if you do have a question, raise your hand and ask away. All right. So just like anything else, there are many very different types of 3D printing. Here I've listed a couple. Fuse deposition modeling is sort of your typical 3D printing technology. This is the one that uses thermoplastics. It melts and it goes layer by layer, one after another. But there are other types that I did want to mention here. SLA. You might have seen as well, it uses liquid resin, uses a laser to cure each layer by layer until you end up with a really nice print. That sort of 3D printing method is really ideal for something like miniatures or something that you want really nice, fine detail. Personally, I am a hobbyist. The FDM type of 3D printing is fine for me. I'm not looking for very fine detail or not having the layers appear as much. There is some post-processing that you can do, like sanding and other ways of post-processing 3D prints. SLA will kind of take away some of that, but I don't like messing with the resin and all that stuff, so I try to avoid it. There's another type of 3D printing technology called selective laser sintering. So this one is, you might have seen where you have a printer, an opening there, and then it has maybe like a powder of metal. And so again, a laser is used to combine or cure the powder into a shape that you send to the printer. For this, I've seen it more on the metal side, not so much plastic, but these are just different types of 3D printing. You'll find that as we go through the presentation, FDM is really the one that is used on the ISS, at least as it relates to plastics. But all that to say, there are different ways to do it. There are different materials as well, whether it's plastics, resins, metals, composites, and so forth. So it really depends on the technology being used and maybe the desired effect for that 3D print. So as we talk about 3D printing, another fancier way of saying is additive manufacturing. And all that means is we're adding to something, right? We're not subtracting. Think of additive manufacturing. Again, we are laying down one layer of plastic at a time. Depending on the nozzle size and other things, it may be very fine or may be very large. But conversely, think of maybe having a block of wood where you're chipping away at it, and you end up with, say, a case like this. So you might have started with a larger piece of wood and chipped away at it. So that would be considered subtractive manufacturing. But through additive manufacturing, we're able to get complex geometries. There's certainly waste reduction, right? Because we're not starting off with more material that then we'll end up with, which is nice. Rapid prototyping is a huge benefit of 3D printing, where I might have an idea in the morning of something that will help me maybe keep my wire organized. I spend some time, model it in software, come up with a nice model, send it to the printer, and by that afternoon, I could have something tangible in my hand that can serve a purpose, which is pretty nice. So in that respect, having an idea and actually having something tangible is a great benefit of 3D printing. Now, with this type of technology, there are certainly a lot of applications for it. It varies very widely. Prosthetics you might have seen are being used for 3D printing, where there may be a certain shape that the arm needs to sit. And so someone will take the time to model something that will keep the arm in a particular angle. And I've actually seen some folks with these types of casts, which is pretty remarkable to see. It's just awesome to see it in real life. Again, automotive prototyping, really any type of prototyping, again, having that idea, coming up with a model, sending it to the printer, and then really finding out, does it actually serve the purpose that I think it will? You might find that it does 80% of the job, but I didn't account for X, Y, and Z. And so instead of spending the time and money having a mold for this particular model, I can 3D print it in plastic and then find out, does it actually do what I think it will? This technology has been used in fashion. I do follow a couple folks on Instagram where they 3D print custom jewelry, which is pretty neat. And even with fabrics, there was someone, I forget who, but they actually do these really neat business cards using 3D printing. So they'll lay down a couple layers of plastic and then lay some sort of, I forget the type of fabric, but it's very fine and very light and stretchable. But then on top of that layer, we'll lay a couple other layers of plastic. And so you end up with a business card that takes that same shape, has the letters and everything. I've been meaning to do that, but I just haven't gotten around. And then certainly for aerospace, lightweight parts. There are a couple of companies that are printing rocket engines using this same sort of technology, of course, made of metal. I think it was maybe this year or last year that a company did launch with a 3D printed metal engine that was created using this type of technology, which is, again, pretty fascinating. So again, circling back and onto some of the advantages of 3D printing in space, that on-demand production, right? So I might have a need for a particular, again, going back to that wire example, I want something that will maybe organize this a little bit better. Being able to just send it to the printer, have it in a couple hours, and then being able to use it, right? Much more efficient than having to So let's make believe we're already in space, having to make a call down to Earth. Hey, we need part XYZ, and now it has to be put onto cargo and sent to the ISS. That certainly takes time, but it certainly takes a lot of money. And I've included here a figure. It costs about $75,000 per kilo of cargo to the ISS. To put that maybe into a better perspective that we'd be familiar with, at this cost, a banana would be about $10,000 just to send that up. So certainly if we had the capabilities of manufacturing in space, we wouldn't need to carry every single thing imaginable with us, and then having all that cost to send it up to the ISS. And then just crew autonomy, right? Crew members can have the autonomy to repair things that might break on the ISS, or say the moon, if we, moon, Mars, wherever we are, using this type of technology, being able to repair things, come up with things that just make life a little bit easier. There's a lot of benefit there. So prior to sending up that first 3D printer, a lot of consideration was taken into, well, how's this really going to work in an environment like the ISS? Certainly, you need to consider microgravity. How does the material behave? Right, because we're melting plastic, essentially, a thread of plastic. Will that work the same way we expect it to? Will it work the same way it does here on Earth, even in that environment? And then something critical with this type of technology is that it really lays on top of the previous layer. So as you're printing something, take this shape that's on the screen right now, it is really printing, and you might actually be able to see those lines. Those are all layer lines. So it laid down the plastic in that thin layer, and then on top of that, another, and another, and another, until you end up with this shape. Will that actually work the same way it does here in microgravity? And then the reliability of the printer, right? It's not like here where we can go to Best Buy or Micro Center or wherever, grab a printer off the shelf, bring it home, plug it into the power, and off we go. If this thing is up in space and a part breaks, what happens then? How do we resolve for that? So all these considerations needed to take place before even getting up there. So before we go on to the next section, I did want to ask if there were any questions about sort of 3D printing in general.
Of all the printing materials, so FDM, FDM, which one is the strongest and most durable, in any-day life, not just the paper, but like prosthetics and for like fashion? What's the most long-lasting and durable?
I would say, and this is more of an opinion, I guess, it really depends on the use case, right? If you are printing something that's maybe going to be outside for a certain amount of time, exposed to the sun, those are things you may want to consider. I've had a couple, I don't have it here, I guess I left it in the car, but I made some signs for the East Brunswick Astronomy Club to put at our table when we go to events like East Brunswick Day and Milltown Day. I left them in the car on a hot sunny day in the summer, and it worked. So that was printed using PLA. I certainly wouldn't do that again. I'd use something more like ABS. Is more of a hardened material that is good for that type of exposure. But it is certainly stronger than PLA, which is what I typically print with at home.
Could it also be used in space as well?
Actually, you will find in a couple slides, ABS was the first, I would say, plastic type that was printed on the ISS. Great question. Any other questions?
How big is each grid?
It really depends on the printer. For these in my research, I wasn't able to find exactly how small the nozzle was for the printers that I researched, but they vary, right? And I would say depending on the size of the nozzle, that will certainly affect the quality of the print because you may get finer layers. However, it will also take a very much longer time to get something, where something like this, let's say maybe 2 hours, 3 hours, but if I use a smaller nozzle, it'll certainly take a lot longer. So that's also something to consider. With the printers that I saw on the ISS, not today, but it is certainly a consideration, having multi-material printing. Here, yes. Yes, one of the printers that I have today allows for 4 spools of material. Again, I predominantly print in PLA, but I could put a different plastic like PETG and then be able to combine. So that's possible today here. Yeah.
How expensive is most of the material for 3D printing? I've seen some videos of like people using 3D printing. They mentioned printing material always being expensive. Kilograms for the PLA is something like, wow.
So if anyone didn't catch it, 1 kilogram, you said?
Yeah.
Is $15 about on Amazon. So depending on what you're doing, you could really go through that spool pretty quickly. So it adds up. All right. So in anticipation of sending a 3D printer, the first 3D printer to the International Space Station, a company called Made in Space ran through a couple different tests simulating microgravity here. And if you could see in the picture, you'll notice they have this pretty impressive rig. So that box right here is the actual 3D printer. So out of all of this, only this part is the 3D printer here. But there are, you can see the spool of material here at the bottom fed into the machine as it prints. And if you take a look, they're at 0 gravity. So we essentially set up this rig to see how would the printer react or behave rather in a 0 gravity environment. And so they ran through multiple tests looking at the material as well. How does that work in such an environment? And then making design adaptations to the machine to ensure that it will work once they get up there. So here, going back to that question, ABS plastic was ultimately picked as the material to be used on this first 3D printer. And what you can see here is actually, does anyone know what that's for? No. This thing right here. Kind of mentioned it earlier, but I don't think you'd know just by looking at it, to be honest. And
Yes, it looks like a wire gun.
Exactly. That's exactly what it is. So, and we'll get into the models that were printed on the ISS in a little bit, but I did find it funny just seeing that here. I would have never guessed that's what it was for. Oh. All right. So here I'll go through a brief timeline of 3D printing milestones on the ISS. Now, it doesn't include every single 3D printing accomplishment, but it'll cover a lot of the top ones, I'd say. So the first 3D printer launched and was installed on the ISS in September of 2014. It was part of the 3D printing in zero-G technology demonstration mission. And here, you can see it all the way in the back there. It's actually inside something called the microgravity science glove box. So this circle is where the astronauts would essentially stick their hands in and then be able to maneuver and manipulate the 3D printer, take prints off the bed, sort of like you've seen maybe on TV. So this was, of course, the first use of additive manufacturing technology beyond Earth. And the print dimensions I included here. But all that to say, it's almost like the size of a large candy bar. So that's all you were able to really print on this first 3D printer on the ISS. And as mentioned, it uses ABS plastic and it ran through April of 2020. Okay. So this here was actually the first 3D print on the ISS. This is the first thing that they printed using this new machine. Again, made in space, that company that developed this printer. This was actually a faceplate that went onto the printer. So in a way, it was a functional print, but I could understand why this would have been the first print. Does anyone have any guesses or ideas as to why this might be a good first print for a printer?
It's simple. It's a simple print where it doesn't have to have a function or anything like that. It's to essentially show testing the features and what the 3D printer could do before it sees the electrical breaker projects. Start small, you can get bigger through constants.
Yeah, I mean, exactly. It's a nice simple shape, good for a machine to handle. There's no curves. There's nothing where maybe there's overhangs or something you have to really worry about printing. Exactly what you said. I keep using the clicker. So these are a couple other examples of models that were printed on the first printer that was on the ISS. So these here are great. I would say, coming back to Irv, on terrestrial 3D printers, there are these calibration prints that you would do to really ensure that the printer is working properly, has good tolerances. And so here, that first one, you can see, okay, we'll do it this way. So it has these overhangs where there's nothing underneath supporting this print. We do that here as well, just to make sure that the printer is heating the material properly and it's cooling it down as well, so that it doesn't slope down. But here we probably use something called supports that will print underneath the intended model to just hold it up as sort of like scaffolding. That it actually is able to print that long piece here. But up in microgravity, do you really need supports on something like this? And then here, these bottom two models, you can see they have circles and squares going from a certain size down to all the way these smaller circles and squares. Again, trying to determine how accurate the printer is able to produce 3D prints. And I have to imagine these were able to fit together and come together into one piece, as long as the tolerances were accurate. Again, the wire organizer. And then supposing the printer is able to manage, these shapes, they fit together, meaning that the printer is well calibrated. You can get something a little bit more complex, like a little container with a lid that you can screw on, right? Because if the ridges are not printing accurately or the overhangs are unable to stay up, there's no way you'd be able to print the ridges on the lid to close on this. They were able to. Just 3D resources, NASA, and you will find a page where all these models are available. So if you have a 3D printer and want to print what they did on the ISS, you can. And it's all free to download and has information on each one of these. Yeah, so here we have astronaut Butch Wilmore holding the 3D printed ratchet wrench from the 3D printer on the ISS. Has anyone seen the wrench before? No? All right. So that is the same wrench here. Again, came from that same web page where it had all those other models. But the idea here was that wrench was actually the first model that was uplinked to the ISS to be printed on that machine. One thing that I failed to mention earlier is that the printer itself was outfitted with a number of different things, a camera to check the printer, and then remote control of capabilities. So this wrench, the idea was, let's come up with a scenario where the astronaut may need a tool that they did not go with. Can we produce that up there and just send it remotely? And they could. And that's the wrench that they did. Unfortunately, I left it in the car. Once we go outside, I'll bring it out, but you'll find it's very satisfying to actually use. It does click like a ratchet wrench. All right. So now, if you know anyone who has a 3D printer, you'll know one printer is not enough. A second 3D printer was sent to the ISS in 2016. This one was called the Additive Manufacturing Facility, or AMF. And it had a larger print volume. It was about 216 cubic inches in volume, much larger than the candy bar print bed that the other one had. But this one was able to print in additional materials. So not just ABS, but these other types of plastics for printing. And here's a picture of the printer itself. And on that second printer, there was a collaboration that was done with Lowe's, where they printed this cobalt wrench. But one neat thing about this wrench is that on the ISS, you kind of have to worry about your tools floating away. So they did add a little clip to the wrench so that it stays put. But besides the cobalt wrench, antenna parts, an adapter to hold a probe, and even these connectors, there are these things called spheres, which are free flying robots used for research on the station. And so these connectors allowed them to connect more than one of those spheres together. But again, showing the capabilities of having the means to create something on the ISS that you may not have traveled with or even have thought of before you left Earth. So this one is actually very near and dear to me. I just love that this happened back in 2015. There was a competition called Future Engineers Space Tool Challenge. And the competition was sent out to students all across the US. Come up with a 3D model that we can 3D print on the ISS that serves a great purpose, that could be used by the astronauts in space. And so there was a high school senior that came up with this model. And that was the winning model. And of course, as part of the prize for winning first place, they printed that student's model on the ISS. And there it is floating. So here, I'll just play a short snippet of a video where the crew talks about this model with the person who designed it.
Gentlemen, this is RJ Hillen. I just wanted to say it's an honor for me to be able to talk to you.
Hey, RJ, we're really happy to be able to talk with you tonight.
The first question I have is, what was your impression of my design of the multi-purpose precision maintenance tool? Do you think it'll be useful on station?
You know, I think this tool will be useful. We were just talking about it, Jeff and I were, you know, and what's cool about it is that oftentimes we're having to look for a deep well socket. Well, you don't really need a deep well socket when you have this because you can hold it in your hand and put it down. And so it has lots of useful pieces on here. You know, one thing that oftentimes with prototyping with 3D printing is there's a plastic version, then a metal version. But even this plastic version, I think, would work up to a certain torque value. So well done, and I think it's really cool.
Yeah, so as part of his prize for winning, he called it the multi-purpose precision maintenance tool. And so if we go back, oops.
Is most.
So it has a bunch of, so a couple of spots where you can add attachments, different sizes here, even grips so that they can hold onto the tool. So it had a variety of uses. It did win first place. And there you saw him speaking to the astronauts on the ISS about his creation, or his design rather. So one of the reasons why I really like showcasing this contest that occurred is because the reality is, I mean, 3D printing will allow you to create pretty much anything. It could be something useful, or it could be a trinket that just sits on your desk, which is nice too. But the possibilities are really endless. And I like that aspect of the technology really appeals to me. So I just love that this competition happened. There was this design that won, was printed on the ISS. I just think it was really, really cool. Great. So fast forwarding a couple years, the first bioprinter was introduced to the ISS in 2019. A little bit more complicated than our plastic printer, for sure. But this was really sent up there to test the ability of printing human tissue in microgravity. Here on Earth, printing something of that nature would be very, very complex. There's some scaffolding that would need to occur so that it prints properly. But the idea was, in microgravity, perhaps we don't have to worry about such things, and you could just print as it floats there. But the larger goal of using such a technology is certainly to be able to print human organs in the future. And it does use something called bioinks, which is living cells and proteins. And this one is actually produced by the same company that created the first two printers that we spoke about. But they've since changed their name to Redwire Space. So no longer made in space, now Redwire.
I have a question about that. I've been hearing a lot of like stuff being making art and art and such. What material is used? Is like that same plastic, but not more flexible?
No.
Legitimate, blood cell and legitimate bone tissue.
So at least as it relates to this first bioprinter, it is using this thing called bioinks, which is not plastic at all. It is living cells and proteins, certainly limited to the things that you are able to print. In the next, so I'll skip to this, but the first human knee meniscus was printed in space in 2023. So producing something like that, they were able to do using that material. Now, could they produce a whole human heart? I don't think they're there just yet, but that's sort of the capabilities as they are right now. So just going back here, I did want to just showcase a couple pictures that were available on the NASA website as I was doing my research. Again, that sort of containment area where you sort of stick your arms in and are able to maneuver the machine. Here you can see. But one of the things I like about this second picture is actually that you're able to see this BFF, again, right? Biofabrication facility is what that bioprinter was called. But then all these smaller packages that came from this larger one. For this printer, something that was really emphasized in the articles that I read was that, and I'm sure it applies to the other printers as well, is that they certainly had to be modular. All the different pieces had to be swappable so that if something were to go wrong with one of the pieces, you're not really having to maybe discard the whole machine. You're able to get resupplied with new components, and then be able to swap out the ones that aren't working so well, or replace the material very easily, right? Because that's certainly something you have to consider as you're sending it up to space. You can't just go to the hardware store, pick up a spare part, replace it. So those types of considerations need to take place for anything that is sent up to the ISS. So we talked about plastic, we talked about bioprinting. Metal 3D printing has occurred on the ISS as well. Back in January of 2024, the European Space Agency, or ESA, introduced the first metal printer to the ISS. And here again, sort of like they did with the plastic one, just researching how well does this blush you? How well does this technology work in an environment on the ISS? For this one, the material used was stainless steel. And the idea there was to really print a variety of different things to help determine, what's the right optimal way to print using metal in microgravity. They also had different size nozzles that they would use, again, to examine the quality of the prints and see, is this feasible? How is the strength compared to the way we print them here on Earth? How does it compare? Okay. So here, astronaut Jeanette Epps configures the metal 3D printer, and you can see the piece right there with the different shapes. I think these were really just sort of that same calibration idea that we saw with the plastic pieces, just to see how do they compare with the ones that are printed here on Earth. And here's a closer shot. So certainly helpful, right? If we have a metal 3D printer, perhaps there's a use case where plastic, even if we change the info to 100, make it real solid and strong, perhaps even then it still wouldn't meet the task that we're looking for. So having the option of printing in metal is certainly a good alternative to have. All right. So as we said, having that capability of fabricating something in space certainly makes it easier to be less dependent on that resupply mission to have to come up and spend all that money to send things up to the ISS. Quick part production, if there's something that maybe we didn't account for and we're able to make a replacement part, all the better for it. And then the customized tools. Maybe there's a tool that we need that we just don't have or doesn't even exist here on Earth. Have someone with the know-how design it and come up with the tool and then produce it where we are. Oops, sorry. Oh, sorry for the font size here. But again, the potential for deep space missions or lunar habitats or Martian habitats, as we look to go to the moon and Mars, there won't be a Home Depot there when we get there and that we can just go to and be able to create a habitat. We have to either take everything that we need from here as it is, or have the capability to produce those things that we need once we get there. I call this talk a brief history of 3D printing on the ISS only because there are other applications for 3D printing. There's even a printer that uses lunar dust or regolith to print. And that's something that's being looked at as well to build habitats on Mars and the moon. But that's something for another day. But this is a very exciting time. Ongoing research into the different types of materials that are available, maybe coming up with optimized materials that will print best on the ISS, or using materials that are available to us on Mars or the moon. Multi-material printing was something that came up earlier, right? Having the capability of using different materials to tackle a different task where it calls for it. And then being ready for, as we explore space, again, having that capability to produce what we need where we are. Any questions? A lens? Yeah, not one that you'd want to look through. I mean, there's clear plastic that you could print with and it'll come out very nice, but I don't know that there is, you would get the quality of a nice lens to be able to see through and get the desired effect, I would say. However, one thing I will note, a couple years ago, my family and I went to Boston I forget the name of the museum, might have just been Museum of Science in Boston. And they did have on showcase a couple sculptures that were made in glass. So using a 3D printer that melted glass and came up with designs. And so, who's to say you couldn't print the lens using the same way? Pardon?
What lens? Like, modern possible lens, depends on what the application is.
Yeah. I'm sure we're not far away from it. Yeah. Who knows? Maybe we're doing it already. I mean, there's dental offices that are using 3D printing today. Good question.
A lot of people fancy, the glass, metal, but well, when we have a couple of one, that's just a random out there question. Be able to 3D print other stuff beyond that, like food or liquid, like water or drinking.
I think that pancake printer,
We printed
really wrong.
Well, I didn't catch that
The
one.
question was about if you print food, and there was an article that was on academic.com maybe years ago where a very enterprising maker printed a burrito.
There's also a pancake 3D printer.
Yeah.
Edible? Cool. Yeah.
I mean, there are even chocolate 3D printers. So it all depends on the machine and the material that you're using with it. The reality is all it's doing is melting it and then laying it down on a predetermined shape or path. So things like chocolate pancakes, right, makes sense that you'd be able to come up with something like that.
It's, people are thinking about making organ and totally doing such. If I could do the same in case we're at a food store, or if we need water, if the water system, there is a way to create a clean food source, water source. In case, for instance, if astronauts go into space, they run out of food supply or run out of water supply. I'm not saying it's gonna happen, but if it did happen, who would be able to get to a point where something like that could happen?
Isn't there something in Star Trek?
The replicator,
Yeah.
and I'm waiting for the replicator. You can pull this one. Why is my printer just
It's printing because it can't make new material. You gotta give it a spool of
Right.
whatever you're printing right now. You have to get to the molecular level to change the material.
Yeah,
that interpreted?
Isaac, everything you talk about so far is small. And some of the 3D printers, they were spending devices now. Some people in Europe, they were 3D print a house.
Yeah. There's a 3D printed house in Long Island. Yeah.
I mean, it's, the technology, concept of technology, but it's not there.
Yeah.
Not only small, but large. I can see on Mars that the way about data.
Yeah, I mean, going back to what I mentioned earlier, I didn't mention a couple things. One was the printer that uses lunar dust to print, but the idea is they could build a structure on the moon using the same way we're doing it on Long Island. Great questions. Any others?
Clearly, they have dealt with the problem of volatile organic compounds on the ISS by sticking it in an isolation box. In more common 3D printing, like something you get at home, how much does it matter? But you have to take significant special precautions when you're printing with a material that has the volatile organic compound problem.
Could you
You don't
explain?
necessarily want to print ABS on a printer that doesn't have a carbon filter. That's not practical anymore. And as you scale up, that problem just gets worse. In larger scale printing, there ain't currently being investigated good solutions to that.
None that I'm aware, but that's not to say there are. I just haven't come across them. Any others? All right, thank you. All right. We won't belabor the next couple slides just because I've been talking too much and the weather is clear and we want to get outside. It's clear out and hopefully we should be able to see Saturn. I think we have the last time that we were out. So maybe we'll take a look at Saturn again, try a couple lenses, get a closer look. We missed the moon. It won't be out until, I don't know, maybe 3 o'clock. So being a partner club with the UACNJ, United Astronomy Clubs in New Jersey, we do like to promote their events. They have 2 events left this year, happening this Saturday, October 18th, and the following one on 10/25. Check their website. I think for the 25th one, you are able to dress up for Halloween, which is always fun. But this is the talks that they have coming up. And they're the last 2. They close down for the winter and then open up again, I think, in March. So for us, we are very busy this month. We'll be doing some sidewalk astronomy at the Woodbridge Public Library on Tuesday, the 21st at 7 o'clock. So if you're free and around, if that's closer to you than East Brunswick Public Library, by all means, come through. And we'll be doing the same thing we're about to do now. Go outside and take a look through the telescope. If you're going to East Brunswick Harvest Fest, we'll be there as well. Just again, because we're a new club, spreading the word that we're here. It's a free club, open to everyone, and just trying to get more folks to come to our meetings. So thank you all for coming. And then doing again some sidewalk astronomy. I listed Woodbridge twice. That should be Spotswood here. Yeah, so this one is Spotswood. We're doing the same thing, spreading the word about our club and doing some sidewalk astronomy. So again, if that's closer to you, come through. Or if it's not, just come on by. And then something very important, every quarter we do try to do a kids meeting. Our next kids meeting is Thursday, November 20th at 6:30, that should say. And the next couple slides talk about what it'll be on. We're doing something on constellations. So if your child loves space and wants to have the opportunity to present like I have today, let us know. Reach out to Christy. Her emails are there at the bottom if you want to take a picture of it. But the idea is they'll give some background information on constellations, how to locate and identify them, and then a fun fact about the constellations themselves. And that's Kevin, our presenter extraordinaire. And then here are some tips. Certainly practice, that certainly helps. Index cards makes things easier and make it fun. But that's what we have in store for our November meeting. If you have any questions, just come up to us, let us know. By all means, keep updated on what we're doing. The best way to do so is to follow us on Instagram and Facebook. So I'll leave it up there for a moment if you want to scan those QR codes. But that is really the way to know what we're up to, where we are, what we're doing. And then open discussion. We do have an opening on our board for a board secretary. So if you are interested in working with an awesome group of volunteers, please let me know. You can come up and ask me a little bit more about the position, what it entails, what we're looking to do. We're getting close to our 2-year mark. We've been able to do extraordinary things, but now we're sort of on our own as we separate from the library a little bit. But we can certainly use the help. So if anyone has the time and would like to volunteer, let me know. And then save the date. Our end of year meeting is on the 18th of December. Typically what I like to do for that meeting is just go over what we've been able to accomplish in the past year, getting food, things like that. So it'll be a nice event. Anyone here at the last one? I see a couple faces who were there. So you can ask them what it was like. It was pretty fun. So certainly save the date and more information will come out. But again, follow us on Facebook and Instagram to stay updated. Thank you all for coming. Thank you for listening. And there's your last chance to follow us on Facebook and Instagram.